Now let's focus on RAG. RAG means Retrieval-Augmented Generation, right? So the first step in RAG is to prepare the input document. For example, let's say you are asking a question to the LLM as what is the email address of HR, and that email address of HR is specific to your domain, right? So assume the LLM has already been trained. This is the base LLM, right? And assume this base LLM has already been trained with the training data. So it will have some generic intelligence, and one of the onboarding documents has HR email address. Assume this input document has your company specific HR email address, and assume this is a text file, right? Do you think this LLM can understand the text inside this text file? No, because LLM can only understand numbers or tokens, right? And LLM cannot understand text. So what is the next step? We have to create embeddings, right? So before we store this in vector database, we have to convert the input document text into embeddings, right? And I will come to the chunking in a bit. So the entire input document will be converted into embeddings, meaning some numbers. And let's assume our input document has around 300 pages. Okay, so can we convert this entire input document into one embedding so that the whole context will be saved in one embedding? But in real time, it's not possible, right? Because we may have huge amount of data, right? We may have like petabytes of data, right? Will the LLM be able to process this huge amounts of data? No, because there is a limitation, and that limitation is called context window, right? Each LLM has a different context window size, right? For example, if you take Claude Anthropic, that has 200k token capacity, right? So it cannot process beyond that. This will represent the maximum capacity for storing conversation history and also generating new output, right? So that is the context window. And if you take GPT 3.5 has 16k tokens, whereas GPT-4 has 128k tokens, right? And if you take Google Gemini 2.0 Flash and Gemini 1.5 Flash, they come with 1 million token context window, right? And if you take the older version Gemini 1.5 Pro, it comes with 2 million token context window, right? And if you go to Meta Llama, each model has different context window. For example, Llama 4 models have 10 million token context window, right? So that is huge, right? So that will allow for more complex and detailed interactions, right? Particularly for tasks like long document analysis and also multi-hop reasoning, right? And Mistral models have variety of context window sizes. For example, Mistral Large 2 offers 128k context window, and Mistral 7B Instruct have a 32.8k context window. Mistral Small 3.1 has 128k context window, right? So each model has a different context window, right? So first of all, what is this context window? Input plus output together is the context window size. For example, let's say when you go to ChatGPT, right? You are asking a question to the LLM ChatGPT, write a program to do bubble chat in Python, right? So that is your input question, right? Once you ask the question, what will happen? The input text will be converted into tokens because the LLM cannot understand text. So that will be converted into tokens, right? That is called embedding. And then it will generate the output, right? For example, let's say the input took 9 tokens and it gave the result, right? And assume the output has around 300 tokens, right? Total together the input is 9 tokens and the output is 300 tokens. The output is nothing but the bubble chat program that it gave, right? So which is 300 tokens. So input is 9, output is 300. Total together is 309 tokens, right? So that total 309 tokens is nothing but the context window size, right? So that is whatever you are asking plus whatever you are getting from the LLM. And when we combine both together, that should not exceed the context window size. Okay, assume you have a huge document and you cannot process the entire document using these models. Then what is the solution here? And if you go ahead and process it, you may get out of context window, right? You may get those errors, and the LLM may ask you to create a new task. And if you initiate a new task, then what happens? In that case, the LLM will lose the context or memory of previous scripts, right? And it won't be able to remember previous memory. That's why many of the models, they are trying to increase this context window size so it can understand the context, right? So the context window play a major role in creating accurate results, right? And for example, assume whatever the input document that we are using, the input plus output response together, assume it is more than 200k tokens. Then what is the solution here? We cannot use this LLM, right? So can we split the input document? So this process is called chunking, right? Here we will do semantic chunking, that is depending on the document we need to chunk. For example, chunk 1 embeddings, chunk 2 embeddings, chunk 3, etc. right? So once you chunk, then we will not run into this context window limitation, right? We can surpass this context window limitation and then still we will be able to process the input document even though the document is large, right? Because we are chunking the input document and then creating the embeddings and processing, right? Next step is we have to store those embeddings somewhere, right? So all these embeddings we will store in a vector database, right? Assume you have 10,000 documents with 2 million paragraphs, right? So every single paragraph will be chunked and then we will create the embeddings. That means it will be converted to numbers and those embeddings we will store in the vector database, right? So far what we did, we chunked our input documents and then created the embeddings and those embeddings we stored in the vector database, right? So the entire document has been converted into embeddings and stored in our vector database. Now let's say the user is asking a question which is related to your domain specific data, right? So for example, let's say you're asking a email address of HR, right? Can LLM understand text? No, right? So then what will happen? It will convert the input, that is what is the email address of HR. Again that input will be converted into embeddings, right? That is some number, right? Then that number will be searched in the vector database and this LLM will try to retrieve the top k, that is top chunks. That is in all the chunks wherever the email address of HR is present, it will try to pick all the chunks and it will pull only the top k. For example, let's say if you give k is equal to 3, then it will pull top 3, or k is equal to 2, it will pull top 2 results, right? So this is the whole pipeline of RAG, right? So what we did so far, so first we prepared our input document and next we did chunking. We did chunk the input document because to avoid the limitation of context window, right? Each LLM has its own context window size. So the context window is nothing but input plus output together total number of tokens, right? And if your input document is huge, then the LLM cannot process, right? So in that case we have to chunk and process, right? So we created chunkings and we created embeddings for each chunk and we stored those embeddings in the vector database, and whenever user asks any question, that question will be again converted into embeddings because LLM cannot understand text, it can only understand numbers, right? And then we will do the search in the vector database and it will retrieve top k. Here k is hyperparameter, you can tune it according to your input document and it will retrieve the top results, right? So this is the whole pipeline of RAG. So you keep your domain specific data in the vector database, so the LLM will go and search in the vector database and it will retrieve the results. So that's the whole theory behind RAG, Retrieval Augmented Generation, right? And in the next lecture, let's see the practical part, then it will be more clear for you. All right, thank you.